In this video, you will learn what is RAG or Retrieval Augmented Generation. We will also understand how different companies use RAG and also a hands-on demo to set up your own RAG pipeline. So make sure you watch this video till the end. Let's go. Before we get started, I have detailed notes created about RAG and it includes everything you should know. So if you want me to share these notes with you, comment below RAG and I will share it in the video description. Alright, now to understand RAG properly, let's start with an example of ChatGPT. If you go to ChatGPT and ask a question, what is the capital of India? It will reply you with an answer because it has been trained on huge amount of data like PDFs, website pages, Wikipedia and lot more that knows that the capital of India is Delhi. But when you ask ChatGPT something internal about your company, for example, how much sales did we make on Saturday? Since ChatGPT do not have access to your company internal documentation or does not know how much sales you have made, it will reply you with an answer saying, I do not have enough context or access to your internal company. Or ChatGPT might just lie or make stuff up. This is because ChatGPT is not trained on your company internal documentation. It has been trained on public internet pages. I hope that makes sense. Now let's try with another example. This is the error I got from a Docker container running in my local machine. If I paste the same error in ChatGPT, ChatGPT might give me a vague answer which is most likely wrong. But if I paste the same error on docs.docker.com in the Gordon Docker AI, it will give me right answer pointing me to the correct documentation and the sources where it got the answer from. So how come ChatGPT gave me a wrong answer but Docker AI gave me the right answer pointing me to the right documentation? The answer is RAG or Retrieval Augmented Generation. So Retrieval Augmented Generation or RAG is a technique that combines information retrieval with large language models to generate more accurate, up-to-date and context-aware responses. And how does it do that? So instead of relying only on what a model was trained on, RAG allows the model to fetch relevant data from external sources, could be documents, PDF, databases, APIs, and use the information while generating answers. So when you ask a question to an LLM, rather than giving the answers from the data that it has been trained on, it will get the data from these sources and then generate the response to give it to you. So without RAG, your model could hallucinate, you can get old information, or you can get responses that it does not understand, or it could be not your data. To explain you this more clearly, I actually have a project in which I'm using a document which is a text file that has information about Japan, and I have two files here, the insert.py and the question.py. I will very soon explain you what it does, but now let's run this file. So if I say python 3 question.py, I can simply ask it a question similar to I do to ChatGPT, but in here I'm using a model which is the Nomic Embed Text model. It's a local LLM that I have on my local machine using Olama. So when I run this file, now you can see it's asking me, put your question. So now if I ask any question related to Japan, it will get the information from this text file. But if I ask anything apart from Japan, let's say if I ask what is Kubernetes, it will give me an answer saying it does not have context or information about it. So let's ask what is Kubernetes. So this is the user query. Using RAG, it will search the document and now it gave me the response saying there is no mention of Kubernetes or any other technology in the provided context. The text only discusses Japan. Now the information is fetched only from the documentation. It is not referencing to any data that it has been trained on. Let's try another example. Let me ask what to eat in Japan. Okay, so now we have the response here which says you can eat sushi, ramen, tempura, all of these, and the information has been fetched from this particular file. I can try another example. Give me 3 days Japan itinerary. So since this documentation has information about Japan, it will give me a 3 days itinerary using the information and generating a response. And so you can see on the first day you should go to Tokyo, then Kyoto, and then Tokyo again, or Osaka, optional. But if I ask anything else, let's say what is capital of India? Since this documentation does not have anything about capital or India, it will give me a response saying it does not have information. So using RAG, you can reference to documentations or text files, PDFs like this to get correct response. In this RAG notes, if you scroll down, you will find a section that says how RAG works, and it has an architecture diagram of a basic RAG pipeline showing you all the components in a RAG setup. For example, LLM, but also has a vector database, which is a special kind of database. This vector database will hold all your internal documents, PDF, etc. but you cannot store them directly. You need to convert the documents into an embeddings or vector using an embedding model, so that whenever a user passes a query or asks a question, the question is also going to be converted into vectors. Now the question vector and the vector stored inside your vector database will be, you will do a search between them, and then the context is passed to the LLM to create a response and then give it back to you. I hope that makes sense. If not, let me show you with an architecture diagram. So let's start with an architecture diagram showing you what happens when you don't use RAG, which is a simple ChatGPT setup. So you will have an LLM or a large language model, could be GPT-4 for ChatGPT, could be Gemini, Claude, Opus, etc, etc, etc. Now, when a user asks a question or gives a prompt to this LLM, for example, it says, what is Kubernetes? This LLM does not understand text, it only understands vectors. So the text is going to be broken down and then converted into tokens, and the process is known as tokenization. So the process of breaking down your prompt and then converting into a token is called as tokenization. Now these tokens will be converted into vectors, also called as embedding. So these vectors are nothing but a long list of arrays that has set of numbers. Length of the array or length of these numbers will depend on the model that you are using. For example, we were using Nomit embed text for the Japan example, and it has a vector dimension of 768 dimension. Here is the query to create table inside your vector database with the dimension 768. But if you're using a different model, the dimension will differ, could be 1536, could be 768, or could be more. For example, in this OpenAI documentation, you can see by default the length of the embedding vector is 1536 for text embedding 3 small model, or 3072 for text embedding 3 large model. So depending on the model, the vector size will differ. But now, once the query or the prompt is converted into vectors, these vectors are then passed to the LLM. LLM, which is trained on huge amount of data, will then use these vectors to find patterns inside the data, and then once the pattern has been found or once the answer has been revealed, it will pass the vector to a decoder. This decoder will convert vectors into tokens, tokens into text, and then pass the value to the user, saying that the Kubernetes is a container orchestration tool. Then this is how the thing works. So this is your basic ChatGPT setup. This is how ChatGPT actually works, where you don't have any RAG setup, where it is not using your internal documents to give you answer. Whereas if you were using RAG, you will have an extra component which is going to be your vector database. So here, this is your vector database. There are different types of vector database like Pinecone, VV8, Milvus. You can also use Postgres database as a vector database, which I'm using inside this Japan example. If you want me to create a step-by-step video to show you how to create RAG pipeline using the example and how to use Postgres as your vector database, let me know in the comment section. Now, when using RAG, you will have a vector database that will store all your documents, PDFs, internal files, etc. Since vector database cannot store file directly, you need to convert them into embeddings, and you do that using an embedding model. So this embedding model will take the documents and then convert them into vectors. These vectors are then going to be stored inside this vector database. Now, whenever a user asks a question like, how much sales did we make? So this information about the sales were present inside this document. The content inside this document is converted into vectors and present inside this vector database. So whenever a user asks a question, the question is then going to be converted into vectors the same way, which is going to be converted into tokens and then vectors. We will use this vectors, which is the question vector, with the vectors present inside this vector database. We will do semantic search. Semantic search is the process of finding closest vectors so that it can give you correct response. Now, when you have some information from this vector database, the vector database will pass that information to the LLM, which will generate some context, frame the answer properly, and then give this answer to the user. So this is how RAG actually works. I hope this explains you everything. And to make it more easier, we are now going to do a hands-on demo where I will show you how you will set up your own vector database, how will you convert your documentations into embeddings and then store into vector database, ask a question and do a semantic search. Everything will be explained. Alright, so now it's time for a hands-on demo. We are going to be setting up a complete RAG pipeline. And for this hands-on practice, I'm using a free lab by CodeCloud. The link is in description. So we are given a scenario where there's a company named as Tech Corp, and the CEO just burst into office saying we have 500 GB of critical documents like policies, products, meeting notes, and nobody can find anything. Our competitors are using AI. We need a solution today. So a CEO is asking to create an AI that can use all these policies, all these documents, and answer questions using an AI. So your mission is to build an AI-powered knowledge assistant that can instantly answer any question about TechCorp's document. So we start by setting up a vector database, which is ChromaDB here. These transformers are going to be used to convert documents into embeddings. There's a web server using Flask, and OpenAI is used as an LLM. Okay, when using Code Cloud Labs, everything will be provided to make sure you easily do hands-on practice. I'm going to just copy and paste this, but to explain you, this command is to install all the dependencies and also ChromaDB. Once it is done, it will give out a message saying ready. So we can go on and check if everything has been installed or not. Let's check this. Check if virtual environment was created, if UV packager was involved, all required packages are installed, setup completion. So everything is done. Let's click on next here. The next step is to explore what document you have. petpolicy.md, remote work policy.md. So you can run this command to see all the documents present inside this particular lab. So you have employee handbook, meeting notes, product specs, customer FAQs. Inside employee handbook, you have all these different things. So you can go check it out if you want. These documents are going to be converted into embeddings and stored inside the vector database that we just installed. So right now we just installed it. We also need to create a collection to store those vector database. So here we are going to be converting documents into vectors and then do a semantic search on these vectors. For this, you need to create AI Brain for storing document vectors, and you have the code here. In this code, we are initializing a vector database, which is ChromaDB, and then we are also creating a collection with the name TechCorp docs. So I'm going to create a Python file with the name init-vectordb.py and then paste the code present in this particular section. So let's create this file, copy the code, paste it here, save it, and then run this using the command cd inside this folder and then run the python init-vectordb.py. So this command is to initialize vector database and also create a collection with the name TechCorp docs. We are also going to be using HNSW index and a cosine similarity search option. If any of this does not make sense, you can simply go and copy and ask ChatGPT about it, but these are requirements for you to set up RAG pipeline. So now it says AI Brain is ready. Let's go and check it if the initialization script was created or if the ChromaDB directory was created as well. Okay, so it's now created. Let's click on next. So the document is broken down into different chunks for easy or better search. This is another file that we need to create. This is a testchunking.py file in which we have a function here, which is going to start chunking for documentation. And here is the sample documentation. So I'm going to just copy and paste by creating a file first. I'm going to run this file now to see if the chunking script was created, chunking test output exists, and verify the chunking count format as well. Ran, it has completed 2 chunks from 526 characters. So you can see the output here. Let's click on check button here and everything passes. So now we have a database. The documents have been chunked. We need to now put the embeddings inside the document. So understand that pets permitted means dogs are allowed. So the similarity percentage is 92%, whereas remote work does not mean dog are allowed. So the percentage is 18%. So semantic search means finding closest vectors, as we have already known. Let's go and create this file. So in this code, you are using All-Mini-LM model to convert words or sentences into vectors. Each vector is going to be converted into 384 dimensions or 84 numbers, as you can see here. So I'm going to just copy this, put this inside the file. Okay, let's run this file again using the command python test embedding.py, and this will create embeddings. So you can see it's using the All-Mini-LM62. This is a Hugging Face model to convert words into vectors, and it has been done. Let's click on check. All right, let's click on next now. Okay, so far we have the documents converted into vectors and we also have a database, but now we need to put that embeddings inside the vector database that we created. So the purpose is to process all the documents using chunking and embeddings into the database. So in this code, we have the function to ingest the document vectors inside vector database. I highly recommend you to understand the code and what you're doing if you are actually doing this lab with me, or else it does not make sense. So Code Cloud provides you with every command and every code, so you can simply go and use it for your reference. If you don't understand it, you can also go and ask ChatGPT about any line of code you want. Okay, so I'm going to save this file and then run the code again. And this will load all the vector embeddings inside vector database. So you can see this first file has been converted into 9 chunks, and then the vectors are created to store inside the database. Let's click on check if everything has been successfully done. And now we move on to the next step. So in this step, we are going to be asking a question which will be converted into vectors, and then a vector search will be done on any of these documents that have been inserted inside the vector database. So the purpose is to build a semantic search that understands meanings, not just keywords. So earlier in the SQL search, it was a keyword search, but now it's a semantic search because using LLM, you can now find words with similar meanings, not exact keywords. So we're going to be creating this file test search.py. So in this code, you have queries like, what is the policy at TechCorp? Tell me about Cloud Sync Pro features. How many days of remote works are allowed? Then it will do a semantic search on the document present. So I'm going to paste this code here and then run the command python test search.py. So it will give me results of all the responses for these questions. The question was, what is the pet policy at TechCorp? Top results by semantic search. It is looking at this file, which is petpolicy.md. And it says employees with allergies should notify HR if they have allergies with pet. It also says that pets are not allowed in cafeteria, conference room, server room, etc., which is exactly what this question is asking. The second question is, tell me about Cloud Sync Pro features. So it is now searching into another document to find the answer, which is cloudsyncpro.md. It says this particular file has 100% match for the question that you're asking. This has 85% match and this has 70% match. So this just means that whenever you ask a question, it is going to do a similarity search on the vectors present inside vector database, referencing to all these documents, because this is what we inserted inside the document. And this is actually what RAG is. Now let's move on to the next thing after we check if everything worked here. Okay, task 8 is to complete RAG pipeline test. Now the purpose is to test all the three phases, which is retrieval, augmentation, and generation. So I'm going to create another file, which is test-RAG-pipeline.py. So I hope this makes sense. If not, you have to do hands-on practice to actually understand all this stuff. And if you have not skipped any previous part of the video, you will definitely understand everything going on here. So now I'm going to create a file, which is test-RAG-pipeline.py. Alright, so the file executed properly, and here we have response. It says, what are the benefits of working at TechCorp? So it first retrieved the information from the document and says found 3 relevant documents. Once it has the information, it is now augmenting it, which means preparing context for AI. Then it will give the information to LLM. LLM will prepare a nice answer and then give back the response, which says, based on the TechCorp documents, employees enjoy comprehensive health insurance, 401k matching up to 6%, and these are all the different benefits of working at TechCorp, which means RAG pipeline is working properly, and we can also check. So all the checks passed. Everything is working now. We need to just give a web interface so that users can go ahead and ask their question easily rather than running through these scripts. Let's go and set up a Flask application, which is going to work on port 5252. Okay, so the app is now running. You can see it's running on port 5252. To access it, you need to click on this 3 dot and then click on view port option and then choose the port, which is 5252 on which your app is running. Click on open port, and now it opens up a UI where I can ask questions like, can I bring my dog to the office on Monday? So based on TechCorp's documents, here's the relevant information. TechCorp policy, dogs are welcome in office every Friday. They're not welcomed on Monday. So this gave me answer based on the document present inside pet policy. So the sources, you can see it's been referenced from this particular source. If I ask something like, do I get family health insurance or just mine working in the company? So now this question is around benefits of working in a company at TechCorp, and it says based on the document health and wellness, it covers 80% dependent, 100% employee, and So this means now the RAG pipeline is working perfectly. So you can now ask your questions and it will give you a response from the document. It will not hallucinate or lie about the answers, which means RAG is working properly. So your RAG system is now live, and try more questions about benefits, products, etc. So you can go ahead and try this out yourself. The link for this lab is in description. This is completely free, so you don't have to pay or buy a Code Cloud subscription. Along with this lab, there are also other 2 labs that I highly recommend, which is this YouTube lab RAG crash course. This is again free, and this has all these different modules. And the last one is this one, which has all the labs. So you have different RAG search methods. If you want to go more deep, understand BM25, hybrid search, etc., you can go and check this lab. So once this is done, you can go and try it out yourself. I hope this was informative. So this was our video on RAG, or retrieval augmented generation. I hope this video was informative. If you have any questions, any doubt, feel free to let me know in the comment section. And if you want me to create a separate dedicated project on RAG, explaining all the settings like temperature, top K chunks, or how to work with different vector dimensions, or how to use Postgres as a vector database, let me know in the comment section. I'm happy to create another video as well. See you in the next video. Bye bye.